Hello everyone. In Geometry for CAT series, we are going to continue with circles, and today let's learn about cyclic quadrilateral. So a cyclic quadrilateral is a quadrilateral whose four vertices are on the circumference, something like this. Let's say this is vertex A, this is vertex B, C and D. Now, if this angle is theta, then the property of cyclic quadrilateral says that the opposite angles of this quadrilateral is always supplementary. So if this angle is theta, this angle must be 180 degree minus theta. If this angle is alpha, then this angle will be 180 degree minus alpha. Now what we can say, that let's say if this side length is A, this side length is B, this is C and this is D, then we can say that area of this quadrilateral ABCD will be equal to half AB plus CD into sine theta. This is the area of this quadrilateral. Now apart from that, we can also use the Brahmagupta theorem to find the area of cyclic quadrilateral, which is S minus A, S minus B, S minus C into S minus D square root, where S is equal to the semi-perimeter, which is A plus C plus D upon 2. So this is how you can find area of cyclic quadrilateral. Apart from this, one thing that you should also know, that in any circle, if there is a trapezium, something like this, there is a trapezium inscribed to it, trapezium A, B, C, D, where AB is parallel to CD, then we will say that this trapezium must be isosceles trapezium. What does that mean? It means that AD will be equal to BC. Okay, AB and DC will be parallel and non-equal sides. AD will be equal to BC, and rest you can use this concept to find out the area. Apart from this, we will learn these concepts through the questions as well. Okay, so we are going to discuss few questions based on cyclic quadrilateral, but before that, let's discuss this question, which says in the following figure, if PC is 8, CD is 10, PA is 9, then find the value of AB. So how do we find the value of AB? So in the first video of circles, we have learned that if two chords are intersecting even outside the circle at point P, then PA is into PB is equal to PC into PD. So we can say what is PA? PA is 9 into PB is equal to PC, which is 8 into what is PD? 10 plus 8, 18. So 9 into 2, 18. We can say PB, length of PB will be equal to 16 centimeter. If PB is 16 centimeter, can we say AB will be equal to PB minus PA? PB is 16 and PA is 9, which gives us 7 centimeter. And that is our answer, which is option B. Now, second question, it says a quadrilateral PQRS is inscribed in a circle such that PQ is to SR, PQ is to SR is 3:4, and QR is to PS is 5:2. If PR and QS intersect at point T, then find PT is to TR. What is the length of PT is to TR? Now think about this. In this triangle PTQ and triangle STR, can we say that angle made by this chord PS on the circumference, which is angle Q, this angle, if I say this angle is theta, then another angle made by the same chord on the same side of the circumference, which is this angle R, will also be theta. Similarly, angle made by QR, this angle is alpha, then this angle will also be alpha, and this angle is vertically opposite angle, which must be equal. So can we say triangle PTQ will be similar to triangle STR, right? Triangle PTQ will be similar to triangle STR. Now the side length, the ratio of side length opposite to this angle, let's say this angle is gamma, then opposite to angle gamma are in the ratio of 3:4. PQ is to PS. PQ upon SR will be same as the ratio of sides against angle theta, which is PT, upon here it will be ST. This will be same as side lengths opposite angle alpha, which is QT, divided by here against alpha it's TR, and all of this should be 3/4, right? Similarly, can we say that triangle PTS will be similar to triangle PTS will be similar to triangle QTR, right? And in that case we can say that QR upon PS will be equal to QR upon PS will be equal to PT upon TQ, PT upon TQ, which will be also equal to ST upon TR, ST upon TR, and this will be equal to 5/2, right? Now what do we want? What do we want is PT upon TR, PT upon TR. Now think, where do we have PT? We have PT here, right? So we can write it as PT upon ST into ST upon TR. So this will be equal to PT upon ST is nothing but 3/4, and ST upon TR is nothing but, okay, QR is to PS, QR is to PS will be equal to QT upon PT. My mistake, this should be QT upon PT, QT upon PT, and this will be TR upon PT. So TR upon PT is equal to 5/2. So here I can write TR upon ST. This should be TR upon ST, not PT. TR upon ST should be equal to 5/2. So this I can write 2/5, right? So in that case, this 2 cancelled out. We get the ratio as 3:10. And so our answer is option B. The amazing use of the concept which says the angle made by the same chord on the circumference are always equal. Next question, it says ABCD is a cyclic quadrilateral such that AB is equal to 9 cm, BC is equal to 3 cm, CD is equal to 11 cm, and AD is equal to 7 cm. So how do we find the area of this quadrilateral ABCD? So what do we know? Using Brahmagupta's theorem, we can say that area of a cyclic quadrilateral ABCD is equal to square root of S minus A into S minus B into S minus C into S minus D. What is the value of S here? S will be equal to 9 plus 3, 12 plus 11, 33 plus 7 by 2. So this is equal to 18 plus 12. This is equal to 15 centimeter, or just 15. Let's take. So 15 centimeter. Now in that case the area will be equal to square root of 15 minus 9 is 6, 15 minus 3 is 12, 15 minus 11 is 4, and 15 minus 7 is 8. So 6 into 4 into 2. So this is equal to 48 centimeter square. So our answer is option D. Next question, it says in the given semicircle, chord BC is parallel to the diameter. BC is parallel to this diameter ED. Further, AB is equal to 12, AD is equal to 20. What is the length of BC? We need to find the length of BC. Now what do we know? That if I extend this circle something like this, okay, can you see ABCD is nothing but a cyclic quadrilateral, and we have just learned this, that if there is a trapezium in a circle, inscribed in a circle, means a cyclic quadrilateral is a trapezium, it must be an isosceles trapezium. What does that mean? It means that AB is equal to CD. So if AB is given 12, CD will also be 12. Now if I draw perpendiculars between these two parallel sides, these two parallel lines BC and AD, let's say this is E and this is F. Can I say BEFC will be a rectangle? Why it will be a rectangle? Because B will be equal to CF. Both of them are perpendicular on the same line, so these two will be parallel as well. So that makes it BCEF a trapezium, a rectangle. So in that case we can say EF will be equal to BC. So somehow if we are able to find the length of EF, we should be able to find the length of BC, because both of them will be same. Now in case of this quadrilateral, AB is given which is 12 centimeter, AD is given which is 20 centimeter. Can I say if I join BC, then why I have joined BC? Because it's given that AD is a diameter, so we need to use some property of this, right? So if AD is the diameter, then angle made by this AD on the circumference will be 90 degree. So triangle ABD is 90 degree. AD is 20, AB is 12. Can we say BD will be equal to 16 centimeter using the Pythagoras theorem? And we can find out the length of BE. How do we find the length of BE? So in right angle triangle ABD, B is perpendicular to hypotenuse. Can we say B will be equal to 12 into 16 divided by 20, which is equal to 9.6 centimeter. Okay, how do we get this relation? Area of the triangle. Area of this right angle triangle will be half into AB into BD, which is also equal to half into AD into B. Comparing those, you get this relation. So we got B is equal to 9.6. Now can I say A? How can I find A? So triangle ABE is also right angle triangle. AB is 2.4 into 12. The ratio of AB and B is 5 is to 4. This is 2.4 into 4. So this will be 2.4 is to into 3. So this A will be 7.2. And similarly, FD will also be 7.2. So what will be the length of EF? 20 minus 2 into 7.2, which is 14.4. So this difference gets us 5.6 centimeter. So similarly, BC will also be 5.6 centimeters. And so our answer is option B. Now, next question, it says in the given figure, radius of the bigger semicircle is 28 centimeter. This bigger semicircle radius is 28 centimeter. So this diameter will be 28 into 2, which is equal to 56 centimeter. Then find the radius of the circle. This circle, there is only one circle visible, so we need to find the radius of this circle. Now these are again 4 semicircles, right? So can we say if d plus d plus d plus d, 4d is equal to 56, each diameter will be 14 centimeter, or radius of this circle will be 7 centimeter. This must be 7 centimeter, right? Now whenever you get situation like this, a circle inside another circle or multiple circle, you need to find something. Try this idea, try to join their centers. So the center of this bigger circle is here, and the center of this circle will be here, right? And again this length will be radius r, and let's say this point is A, this point is O, and if I join these two, this will be like this. This length is 7, this length is R, this is B, this is D. BD will be our radius 7, DA will be radius R, OA will be, this whole radius is 28, so this will be 28 minus R. So now you can use the Pythagoras theorem very easily here. Can we say 7 plus R whole square is equal to 7 square plus 28 minus R whole square, right? So from there, if I break this, this will be 49 plus 14R plus R square is equal to 49 plus 28 square is 784, right? So 784 minus 56R plus R square. Now in that case, we can cancel out few terms, which is 49 cancelled out, R square cancelled out, or we can say that 70R is equal to 784. And if we divide it by 7, what do we get? We get R is equal to 784 divided by 70, 7 times 10, 7 times 112. So we get R is equal to 11.2 centimeter, and that is our answer, which is option C. Okay, so just join the centers. Remember this line, join the centers, and you will get your answer. Okay, so with that we are done with this session. Thank you.